Okay, let's move further. On your screen to the left, you see an observer observing a stick that has been immersed into water. So the stick has been immersed in such a way that the part of the stick that is shown by XO from here to here is above the level of the water, whereas OP is immersed inside water. Okay. Now consider the end of the stick, that is P. So consider this point P. If you take an incident ray, this incident ray, and you take another incident ray, this one. So both these incident ray, because they are hitting the boundary of two media, they get refracted along this in this direction, and this ray gets refracted in this direction. So these two refracted rays, they reach an observer's eye. Okay. So the observer is able to see the object at point P. So when you have drawn back the direction of these refracted rays, they will meet at point P. That is the point where the observer sees the image of the tip of the stick. Likewise, if you consider various points along the stick, okay, so observer will see an image of their corresponding images on the dotted line OP. So ultimately, the immersed portion of the stick appears to be bent at point 0, and it is slightly raised from its real position. So the stick appears to be bent at 0, and it appears to the observer as a line OP dash, but the real stick is OP. Clear? So this phenomenon is apparent bending of the stick under water. Let's move further. Now here the observer was watching an object inside the denser medium from rarer medium. Now in the next setup, the observer will watch from denser medium when the object is in the rarer medium. Okay. So consider an object at point O, and the observer is watching this object point O from inside the liquid. QB will be the incident ray. Because it is moving from rarer to denser, it gets refracted along DC. And when we draw this refracted ray backwards, and we consider another incident ray which enters the boundary normally, so this refracted ray again is refracted along the same direction. So when you draw backwards this second refracted ray, they meet at a point I. So the observer who is watching from inside denser medium, he watches the object O makes an image at point I. So the object at O makes an artificial image at I. So for an observer, it is as if the object is placed at point I. So when the observer is observing from denser medium and the object is placed in the rarer medium, the object appears farther from him. Whereas in the earlier case, when the observer was watching from rarer medium, when the object is inside the denser medium, the object was apparently nearer to him. Okay? So these two phenomena we should note. Okay. So due to refraction, all these phenomena are occurring. But in the end exam, mostly real life examples of the refraction of light are asked. So some of them are listed here. The first one, if you see, a star is actually originally not blinking, but the light from star, it passes through atmosphere. Because atmosphere is made up of different media, or it is made up of air having different densities and temperatures. Due to refraction, the light gets refracted again and again in a haphazard manner, and then it reaches the observer eye. So for this observer, the star appears as if it is blinking, whereas in actuality the star is not blinking, but due to refraction of its light through the atmosphere, the star appears as if it is twinkling. Okay, second example, an observer who is standing on the face of earth. Okay, as the sun rises, in actuality he cannot see the sun, but due to refraction, this incident ray gets refracted and reaches the observer. Although the sun has not yet arisen, like it has not moved above the horizon, so but the observer sees as if the sun has already risen, just moments before the sun actually had risen. So this is called advanced sunrise. This phenomenon is called advanced sunrise. Likewise, actually the sun had set already, but due to refraction, the light reaches the observer, so he can still see the sun. Although the sun has actually set, for for the observer, still the sun has not set. This phenomenon is called delayed sunset. So this is another real life example of refraction of light. Then the third one, suppose there is no water inside this beaker. So when the observer is seeing, he can see like this. So he can't see the coin which is at the bottom of the beaker, because the light from here, it doesn't reach the observer. But when we place water, when we fill this beaker with water at this boundary surface, this incident ray will get refracted and reaches the observer. So due to that reason, initially the observer watching above the rim of this beaker cannot see any coin inside the beaker. But as you start pouring water, and when you pour water, after it reaches this point, he can see the coin, although he could not see it earlier. This is due to refraction. Then the printed, if you place any glass block on a printed material, the print appears to be raised. So as if if you see, if you watch carefully, this print appears to be raised from surface of the paper. So this is again due to refraction. Then if somebody is sitting near the pool and he is immersing their leg until knee inside water, and if they look at their own legs, this length appears to be shorter. This is again due to refraction. Then when you are driving on the road, you must have seen, especially during summer, hot summer afternoons, so we will see as if there is some pool of water. In fact, as the motor arrives closer to it, there won't be any water. This is called a mirage. Why this is formed? See, from this point, the light will reach the observer. So this is clear. Till here it is real. But but some portion of the incident light, it it gets bent like this. The reason being, here the air is hot, because it is hot summer. This air is very hot, is very hot. Due to this difference in refractive index, so this ray is bent and an artificial image of the sky is formed here. So this image of the sky, it appears as if it is a pool of water. This is due to refraction. Okay. Now another example is when after a rainfall, sometimes we see a rainbow occurring in the atmosphere. This is because when the sunlight enters a rain droplet at this boundary, the light ray gets refracted. So different wavelength of light has different degree of refraction or different angle of refraction. So this light ray is split and it reaches the opposite boundary. Here again it is reflected. Then when it reaches this boundary, again refraction occurs. So for an observer, this incident light, it is it is like spread into spectrum of light and dividing it into colors, Vibgyor colors. So that's the reason why after a rainfall, because the light enters through the molecules, water molecules suspended in air, the phenomenon of rainbow occurs. Okay. So in the end exam, you can expect these real life examples. They will ask you why it is occurring. So you need to explain the logic behind it. This is a very common question. You can definitely expect one question on real life example. Clear? Okay. Let's move further. Now, consider two media, glass and air. Okay. And consider an incident ray along this direction. So when it reaches the boundary of the two media, it gets refracted along this line. Okay. So let me draw refracted line with black. So black is refracted ray and red is incident ray. Okay. Now what will happen if I increase the angle of incidence? Suppose I take the angle of incidence like this. So the refracted ray also gets displaced further. So if I go on increasing the angle of incidence, refracted ray moves towards the boundary. And at a certain angle of incidence, the refracted ray, it, it follows the boundary of the two media. Or in other words, it makes an angle of 90 degrees. That is, angle of refraction would be 90 degrees. Okay. So what is the phenomena we are seeing here? An incident ray, part of it is reflected, only a portion of it is refracted, and major portion of it is refracted. So as we increase the angle of incidence, the angle of refraction keeps increasing. At a certain point, the angle of refraction is along the boundary of the media, or in other words, it is making 90 degrees with the normal. So this is called critical angle. So the angle of incidence at this juncture is called critical angle. Okay. So what is critical angle? It is the angle of incidence at which the refracted ray follows the direction along the boundary of the media, or in other words, making 90 degrees with the normal at the point of incidence. Okay. Now if you increase your angle of incidence further beyond the critical angle, then there is no refraction at all, and the entire light is reflected along this direction. So this phenomenon of no refraction at all is called total internal refraction. Okay, so clear? So as the angle of incidence increases, the refracted ray moves closer to the boundary of the media. or in other words, the angle of refraction keeps increasing. At a certain value of incidence, the angle of refraction makes 90 degrees with the normal at the point of incidence. Or in other words, the angle of refraction moves along the boundary of the media. This angle of incidence is called critical angle. A portion of light is also reflected at this juncture. At critical angle, a portion of light is also reflected. But when the angle of incidence is increased beyond the critical angle, there is no refraction that takes place, but the entire light is reflected in the media, in the second media, or in the first media itself. So this is the incident ray and this is the reflected ray. There is no refraction. This phenomenon is called total internal reflection. So for any media, there will be a critical angle of incidence. So if the angle of incidence is increased beyond critical angle of incidence of a particular media, then there won't be any refraction. The media behaves, or the boundary of the media behaves as if it is a mirror. This phenomenon is called total internal reflection. Now, as per the definition of refractive index, refractive index of air, that is second media, with respect to glass. Refractive index of air with respect to second media. Refractive index of second media with respect to first, that is air with respect to glass, is given as sine of angle I, sine of angle of incidence to sine of angle of refraction. This we are doing it for critical angle, when angle of incidence is equal to critical. For this position we are doing this. So refractive index of air with respect to glass is given as sine of angle C, where C is the critical angle, by angle of refraction is 90 degrees, which is nothing but 1. Sine 90 is 1. That means refractive index of air with respect to glass is given as sine C. But we are more interested in refractive index of glass rather than air. So if we inverse this, we will get refractive index of glass. So refractive index of glass with respect to air is inverse of refractive index of air with respect to glass. So if I substitute the value of this here, so I can take refractive index of glass with respect to air as 1 by sine C, or 1 by sine C is nothing but cosecant C. So this we need to remember. So relation between refractive index of any medium and its critical angle is refractive of that index of that medium with respect to air is equal to cosecant of critical angle in that medium, of that medium. Clear? So if we rearrange this equation, we can also say sine C is inverse of refractive index of that medium. So these two we have to remember. Now looking closely at these two equations, we can easily say that the critical angle of any media depends on refractive indices of the pair of the media. Okay, and in other words, the temperature critical angle depends on the temperature of the media, and then it also depends on the wavelength of the light. So you can easily deduce what will happen when the temperature of a media rises. When temperature of media rises, density decreases. When density decreases, refractive index also decreases. Okay, so the fall in temperature, if the temperature of any media is decreased, then its critical angle decreases. And likewise, when the wavelength of a light decreases, its critical angle decreases. So if you remember your stack here, so vacuum and then diamond at the bottom, or your reverse Wisger stack. So as we move from top to down, critical angle decreases. Okay.